Math 3, Unit 4, Section F, or Section 4.6. Today we're talking about function operations. And so if you look here at each of these concepts, if you have f plus g of x, basically you can separate this into f of x plus g of x. Okay, so you're just going to be adding two separate problems. Same with subtracting. Okay, when you're multiplying, if they have it like this, you're going to multiply the two. These are like, they're going to end up labeling these. Like if you look down here, it's telling you that f of x is 2x squared plus 8 and g of x is x minus 3. And so like on this one, you would end up just multiplying those two things together. And then basically, if it's dividing, you can divide the two terms, but g of x cannot equal 0. There should have been a comma in between here. Okay. All right, so we can come back to this and look at it if we need to, but those are kind of the rules. So starting here, where it says let f of x equal 2x squared plus 8 and g of x equal x minus 3, it says f plus g. So all we're going to do is add those two terms together. Can we handle that? Okay, so if we write out f of x is 2x squared plus 8, good, plus x minus 3. And then we are just going to combine like terms. And so we have 2x squared plus x, and then 8 and negative 3 makes 5. Okay, the other thing it's going to ask you for is your domain. So domains, the things we have to worry about is if there were a fraction, 0 in the denominator would make it undefined. So we couldn't have that. So the domain would have to say x can't equal whatever would make the denominator 0. Another thing we can't have is negative numbers under roots, square roots or even roots, because odd roots, they're okay, right? And so we just have to be aware of that as we're doing some of these problems. So in this case, though, every number will work. So this is where we just put all reals. Okay, so when you have f minus g, the only thing you have to be careful of is that you're subtracting g. So you're subtracting the whole thing, and so you want to put g in parentheses and distribute the minus through. So we'll go ahead and write down f. So that's 2x squared plus 8, and then minus x minus 3. And so we need to end up distributing this minus through. So we get 2x squared plus 8 minus x plus 3. And so go ahead and simplify that by combining like terms. And what is the domain? So the only thing that combined was the 8 and 3. So you should have 2x squared minus x plus 11. And then what is the domain? All reals. Because we don't have to worry about any fractions with 0 in the denominators. There's no roots. So any number, positive or negative, would work. Okay, so on C, f times g, we're just going to multiply the two terms together. So we have 2x squared plus 8 times x minus 3. And so it's up to you on how you want to multiply that. You could use your FOIL method or distributive property, or you can use your box method. So I'm going to go ahead and use the box method because I feel like it keeps everything organized. So I'm going to make a 2 by 2 box. And it doesn't matter which side you write things on. So we have 2x squared and 8 and x and negative 3. So we go through and multiply. X times 2x squared is
2x cubed.
Good. And then x times 8 is 8x. Negative 3 times 2x squared is good. And negative 3 times 8 is perfect. And then do you see any like terms there? No. So whenever you're writing your answer, though, you want it in descending order. So I'm going to write this as 2x to the third power minus 6x squared plus 8x minus 24. So remember, descending order starts with highest exponent, and then you just keep going down from there. And so that's my answer. And then what would be my domain on this one? Good. Okay, so the last one, f divided by g or f over g, we have 2x squared plus 8 over x minus 3. And so if you could simplify this, you would. If I could like factor the top in a way that could end up reducing the denominator, I would. But in this case, is there anything really I could do? No, I mean I could take out a 2, but it's not going to allow me to do anything, so you don't have to. So my domain, though, on this one is slightly different because I do have a variable in the denominator. And so what can the denominator not equal? What would make that 0? 3. And so my answer would be all reals except x cannot equal 3. If you're ever unsure, you can always just set the denominator equal to 0. So if you just went x minus 3 equals 0 and you solved to see what would end up making the denominator equal to 0, you would end up solving to get x equals 3. So if you're ever unsure, just set the denominator equal to 0 and see what happens. Questions? Okay, so we're going to move on to the next page. Okay, so these are called compositions of functions. When you read them, notice that it has, this isn't a multiplication sign, it's kind of like that little circle there. This means g of f of x. And what that means is that it's g of f of x like this, where you first start with your innermost parenthesis. So you'd find the answer for f of x. Once you find that answer, whatever that answer is, you find g of that answer. Okay? So it could also be g of, or f of g of x, and vice versa. Does that make sense? Okay, so when you look down here at these examples, they can be written either way. They can be written like this, or like this. Either way, you start with your innermost parentheses. So even like here on C, g would be your innermost parenthesis because it's next to the -2. So you're just starting with the inside, okay? So let's go back to A. So it's saying g of 0. What this means is that we are going to take 0 and plug it into the g equation and solve. This side of the equation is just telling you that that is the g equation, okay? So this means go to the g equation, and in the g equation, which is x squared plus 1, plug in 0. So just to go back and look at this, I'm going to write x squared plus 1. That's what I'm starting with. And then we just plug in 0 for x. So I end up with 0 squared plus 1, which equals what? 1. Okay? And so now that I have the answer of 1, what happens is that this answer is what g of 0 actually equals. So this now is going away, and we are finding the answer to f of 1 now. So it's like a two-step process. We find the answer to g, and then g of 0 we found is 1. So that means that we're going to replace g of 0 with the 1, because that's what the answer to that is. And then we're going to find f of 1. And so now we go to our f equation, which is 3x minus 2. So I'm going to write 3x minus 2. And this time when I see x, what am I going to plug in? 1. So we write 3 times 1 minus 2. 3 times 1 is 3, and 3 minus 2 equals 1. And so that is my answer. Okay, do we have questions? Does it seem difficult? No? Okay, so what will I do on B? What would be my first step? Good. So I'm going to go ahead and write the f equation so that I don't get confused. So I'm going to write 3x minus 2. And then in this equation, wherever I see x, I'm going to end up replacing it with 2. So we have 3 times 2 minus 2. 3 times 2 is 6, and 6 minus 2 is 4. So that means since f of 2 is 4, this goes away, and we now are putting 4 in that spot. So that means I'm finding g of 4. So we go to our g equation now, and I'm going to write that down, and that is x squared plus 1, and this time what am I going to substitute in? 4. So we have 4 squared plus 1. 4 squared is
16.
Good, and 16 plus 1 is 17. Okay, any questions? All right, C. What will I start with first on C? Good. So we always start with the insidemost, the one that's closest. So g of negative 2, so my g equation I'm going to write down, which is x squared plus 1. And I'm going to plug in what?
Negative 2.
Good. So we just plug in negative 2 for x, so we have negative 2 squared plus 1. Negative 2 squared is 4, and 4 plus 1 is 5. So this part has now gone away, and now my equation will be for what? Of what?
5.
F of 5. And so my F equation is,
3x minus 2.
good, 3x minus 2. So 3 times 5 minus 2. And we get 15 minus 2, which is 13. All right, so on this next one it says g of g. So that means we take our g equation, we plug in 1 and find that answer, and then we plug it back into the g equation again. Okay, so I'm going to give you guys a minute to try that one on your own. When you get your answer, show it to me on your fingers. Good. 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 All right, so the correct answer was 5. I'm going to go ahead and get started on it. G of 1. So our g equation is x squared plus 1. We plug 1 in there, so I have 1 squared plus 1, and I have 1 plus 1, which equals 2. So this part now has become 2. So now I'm going to find g of 2. And so we go back to our g equation again, and which is x squared plus 1, and this time I plug in 2. So 2 squared plus 1, and 4 plus 1 does equal 5. Do we have any questions? No? Okay, I can see some of you still writing, so I'm going to wait a minute. Okay, so going down here to the bottom now, they want us to find 2 different answers, okay? So they want us to find f of g of x and then also g of f of x. So when we're starting with g of x, and then once we get the answer, we're plugging it into f, and then vice versa. Now, if you notice on these, before we had numbers. This, they have x's, okay? So we're going to start with, oops, it's fine, I'll get rid of it. F of g of x, okay? So what is the answer for g of x? What does g of x equal?
3x.
3x. So what's happening now is that all I have to do is take 3x and plug it in here. We're just substituting. Okay, so since g of x equals 3x and we don't have any numbers, this is just going to go away and I'm going to put 3x into that spot. So that means now I have f of 3x. Are we okay with that step?
Mm-hmm.
So that means now in my f equation, and so I'm going to go ahead and write my f equation down. 2x squared plus 1. Wherever I see x, instead of writing x, I'm going to write what?
3x.
3x. So we would write this as 2 parenthesis 3x squared plus 1. So all I did is wherever there was an x, I just put 3x in there instead. And then we're just going to simplify. So what would I do first in order to simplify here? Good. So we would distribute this 2 has to go to the 3 and the x. Okay? So what is 3 squared?
9.
9. And then we have x squared plus 1. And then what's 2 times 9x squared?
18x squared.
Good. So I have 18x squared plus 1. That's it. That's my answer.
Oh.
Because there's nothing further I can simplify. Anything I need to re-explain on that one? Okay. All right. Okay, so that was f of g of x. So now we're going to do the opposite one, and we're going to do g of f of x. Okay, so that means what's going to end up going inside here? The f part, right?
X plus 1 over 2.
Good, so this is going to be g of 2x squared plus 1.
You're on the next one, Jordan.
What? Oh, I'm stupid.
No, you're not.
Just a bit.
Okay, so see, notice, and you'll notice this in your homework too, that they're going to have you do two things. So we're doing the second thing. So I'm doing g of f of x. So since f of x is 2x squared plus 1, I'm just taking this away and plugging in what f of x actually equals. Is that good? Okay, so now since it's saying g of this, let's write down our g equation. And our g equation is just what? 3x. So then what am I going to write?
3 times 2x squared plus 1.
That's it. 3 times 2x squared plus 1. And we'll distribute that and simplify. And so we end up getting what?
6x squared plus 3.
That's it. That's your answer.
Wait, where'd the x go? Or, because it was 3x, and then like, where did that x
So, okay, let me just kind of walk through this real quick. So we had g of f of x. And this equation, f of x is 2x squared plus 1. So we took that away and wrote 2x squared plus 1. So far, so good? So now it's saying g of 2x squared plus 1. Well, my g equation is 3x. So I wrote 3x. And so, but now we're going to take this and plug this in anytime we see x. And so I ended up with 3 times that.
Okay.
And then we simplified. Okay. Any other questions on that one?
Would you just leave it like that, or would
Yeah.
you try to find a DCF too?
So if you were to find a GCF, you'd end up going back to this
Oh,
place.
yeah, that's true.
And so when we're simplifying, we're just getting rid of the parentheses and combining any like terms. So we don't have to factor or do anything like that. Okay. All right. So next one, let's start with our f of g of x again on B. So the first thing we're going to do is just replace g of x. And so this g of x, we're going to just substitute in our 3x minus 5 for g of x. And so that means I have f of what?
3x minus 5.
Very good. Okay. The next one now is my f equation, right? So I'm going to write my f equation first. Okay. So my f equation is x plus 1 over 2. But since I'm saying f of 3x minus 5, we are taking this 3x minus 5 and plugging it in for x. And so when I write that, it's going to end up being what?
3x minus 5 plus 1 over 2.
Perfect. And then we would simplify. So we have 3x, and then negative 5 plus 1 is what?
-4.
Good? Over 2. And like, if you could reduce the 2, like if both numbers were divisible by 2, we would reduce them, but we can't in this case. And so that's my answer. Okay, questions on that one? Do you guys want to try the B part on your own? Okay, I'm going to give you a minute to try that one on your own. So this is where we're doing g of f of x. If you get the answer, raise your hand and I'll come check it out. you go 3, I think this is 3 over 1, so you need just multiply that through. Hold on, I think I'm gonna go through this one just to make sure. You guys are gonna have to get common denominators and stuff at some point. But it's not super difficult, but just so that you're not wasting a lot of your time. Okay, so starting with g of f of x. Since f of x equals x plus 1 over 2, this is just going to be replaced, right? With x plus 1 over 2. We're good with that? Okay, so now g of x plus 1 over 2. Let me first just write what my g equation is, which is 3x minus 5. And then all we're doing is taking this and plugging it in for x, correct? So that means I have 3 times x plus 1 over 2 minus 5. Now, if you were able to like reduce the 3 and the 2, you could. What you need to remember is that this 3 is over 1. And so with fractions, you multiply the tops with the tops, bottoms with the bottoms. So I'm going to have to distribute the 3 through the top, and I get 3x plus 3. And on the bottom, 1 times 2 is what? 2. Now here, I just have minus 5. Okay? But I can't combine minus 5 here because this one is a fraction and this one is not. And so we have to, this is over 1, and so we have to get a common denominator. So what denominator would I end up using? 2. So I'm going to put this over 2. And so 1 times 2 is 2. So 5 times 2 is 10. So I'm going to just cross this out, and I just made it 10 over 2 instead of 5 over 1. So now can I combine them together? Yeah. And this, you need to remember, is actually, and if you want to bring it over, this is a negative 10, correct? And so I can combine the 3 and the negative 10 together, and so I end up with what?
3x minus 7 over 2.
That's it. And can I reduce or simplify there at all? Nope. So that is my answer. Any questions? Anything you want me to go back through that we already did on this lesson? Yeah, not too bad.
Just the fractions in the lesson.
Yeah, so just if you're not going to get too many, but just remember to get common denominators if you're adding or subtracting.